Namaste everyone, welcome to the class again. Now in the last lecture we have seen Bayes theorem. Let us revise that Bayes theorem once again. For Bayes theorem we have a sample space. That sample space is divided in some partition. Now let us say we have divided this sample space in 3 partitions like this. This is E1, this is E2, this is E3. It can be divided in 2 partitions, 3 partitions, 4 partitions or n number of partitions. And there is an event A. Now see, this is an event A. Now this event is happening after event E1 or after event E2 or after event E3. Now Bayes theorem is applicable when it is known that event A has been occurred and we have to find the possibility of event E1, that is it has occurred because of event E1. So this Bayes theorem is probability of cause. Probability of cause means for what reason this event happened, for what, right? So that means here our problem is to find possibility of say E1 when A has been already occurred. Now if we use conditional probability, then it is something like probability of E1 intersection A divided by probability of A. Now here I am going to use 2 theorems. First is multiplication theorem and second is total probability theorem. Now total probability theorem, this probability of A. Probability of A will be like probability of E1 into probability of A by E1 plus I want to find probability of this A. So this A, how I can get? I will first find probability of E1 into probability of A by E1, that will give me this part, then plus probability of E2 into probability of A by E2. So by this I will get the second part, which is this part, plus I have probability of E3 into probability of A by E3, and this will give me the third part, which is this one. So by this I can get this possibility of A, and numerator possibility of E1 intersection A, E1 intersection A. So it is nothing but probability of, say I will say that probability of E1, again Bayes theorem we are applying, into probability of A by E1. Now if you don't see this diagram and you just want to apply formula, then from here what we are doing, we are writing probability of E1 into we are writing probability of A by E1. So we are just flipping this part, and as we have done this part, now the same thing we are applying for E2 and E3. So number of partitions, so you have to check how many partitions you have done, and based on that you can apply. In formula form we say that probability of EI by A is EI, say EI by A is equals to probability of EI into probability of A by EI whole divided by summation of probability of Ej into probability of A by Ej, where this j is from 1 to n. So this is for n partitions. Now this I have discussed formula. For complete understanding of this probability Bayes theorem, you have to revise topic called conditional probability and multiplication theorem and total probability theorem. So you must have you have a better idea of what this Bayes theorem is. Okay, or else you can understand this Bayes theorem from this diagram also. So your requirement was that you have to find the possibility of E1 when it is known that event A has occurred. So that means diagrammatically, if I say I have to find the possibility of this part divided by this whole A part. Okay, generally what we are doing, we are finding the possibility of this A part when I know this E1 part. So this divided by this part or this divided by this part, but here reverse is happening. I am using this divided by this whole part, and this is how we are doing it. Now let us solve few problems of your exercise that will clear the things in a better way. Okay, so let us discuss this first problem. An urn contains 5 red ball and 5 black ball. A ball is drawn at random, its color is noted and is returned to the urn. Moreover, 2 additional balls of the color drawn are put in the urn and then a ball is drawn at random. What is the probability that the second ball is red? So, what is the probability that the second ball is red? Again, understand the question. We have one urn and that we have 5 red and 5 black ball and we are drawing one ball at random. So first say I drawn a red ball. Okay, I will note its color. Then again I will go to the urn and I will put 2 additional balls of the same color. So if I had drawn red, so I will put 2 more red balls. So total ball will become 5 plus 5, 10 plus 2, 12. Total ball is 12 and red ball will become 7. And then I will draw again a ball. Okay, now this time the second ball drawn is red. Okay, now one more condition can happen, that first I will draw a black ball. Then in that case what will happen? I will put 2 more black balls in the urn and then I will draw the second ball. And now in this case second ball is red. What is the probability that the second ball is red? We have to find the probability of second ball to be red. That means here we have to find total probability. Okay, here we have 2 partitions, I will say, of a sample space. I have to find total possibility. I have 2 partitions. Okay, an urn has 2 colors, 5 black and 5 red. Okay, here let us define, I will say that in solution, let E1 is the event first ball is red and E2 is first ball is black. E2 is first ball is black and A is second ball is red. Ball is red. Okay. Now, possibility of even. As per the problem, possibility of even, that is first ball is red, is 5 upon 10. It is 5 divided by 10, which is 1 divided by 2. And possibility of E2, this is also 5 divided by 10, which is 1 divided by 2. Now, possibility of A when even has occurred. Even has occurred means I have drawn a red ball. So, when I draw a red ball, now I will put 2 more red balls and the total number of red ball is 7. So, it is 7 upon 12. And possibility of A by E2, that means first ball drawn is black and then I am drawing a red ball. So, now I have 5 red ball only, okay, because I have put 2 black balls, my total number of ball will become 12, but number of red ball will be 5 only. So, it is 5 divided by 12. And I have to find possibility of A, that is second ball is red. So, possibility of A is what? Using total probability theorem, I will say that P of A is equals to P of even into possibility of A by even plus possibility of E2 into possibility of A by E2. So, possibility of even is 1 by 2 into possibility of A by even is 7 upon 12 plus 1 by 2 into 5 divided by 12. So, this 1 by 2 we can take common. Here inside bracket we have 7 divided by 12 plus 5 divided by 12. This gives us answer as 1 divided by 2 into 7 plus 5, 12 upon 12 is equals to 1 divided by 2. So, this is the probability of A, that is probability of getting second ball red. So, here the first problem they have given, it is of total probability theorem. So, again if you have any confusion, revise that second probability theorem. Okay. Now, let us move to the second question. A bag contains 4 red, 4 black ball. Another bag contains 2 red and 6 black ball. Now, in this case I have 2 bags, bag 1, bag 2. Okay. Now, in bag 1, 4 red ball and 4 black ball, and in bag 2, 2 red ball and 6 black ball. One ball of the 2 bags is selected at random. One of the 2 bags is selected at random, okay, and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from first bag. Okay. So, here I will say that of the sample space I have 2 partitions. Okay. Now, I will define E1 as the event of drawing bag 1 or event of selecting bag 1. E1 is what? Selecting bag 1. And E2 is event of selecting bag 2, and I will define A as the red ball is drawn from bag. red ball is drawn from bag. Now, possibility of E1 selecting any of the two bag is what? 50-50. So, possibility of E1 and possibility of E2, they are 1 by 2, 1 by 2. And possibility of selecting a red ball when we select bag 1 will be 4 upon 8, that is 1 by 2, and possibility of selecting a red ball when we select second bag. So from second bag to get red ball is 2 upon 8. That is 1 upon 4. Now we have to find possibility of selecting first bag when we know that it is a red ball. Find the probability that the ball is drawn from the red bag, from the first bag. We have to find possibility of E1. We have to find possibility of E1 when it is known that ball drawn is red. So now this is a perfect case of Bayes theorem. So I will say by using Bayes theorem. Probability of E1 by A will be equals to probability of E1 into probability of A by E1 divided by, I will write probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2. So this is equals to probability of E1. What is the possibility of E1? It is 1 by 2. So this is 1 by 2 into A by E1. So possibility of A by E1 is 1 by 2. So 1 by 2 into 1 by 2 whole divided by, here I have 1 by 2 into 1 by 2 plus possibility of E2 is 1 by 2 into 1 by 4 plus 1 by 2 into 1 by 4. Now this is equal to 1 upon 4 divided by, this is 1 upon 4 plus 1 upon 8. This is equals to 1 by 4 divided by, it is 2 divided by 8 plus 2, 1 divided by 8. So I will get 1 divided by 4 whole divided by 2 plus 1, 3 divided by 8. So this is 1 divided by 4 into 8 divided by 3, 4 1 the 4 2 the. So answer is 2 divided by 3. So possibility of getting a red ball from bag 1, possibility of getting red ball, we are getting red ball, that is sure. Possibility of getting red ball from bag 1 is 2 by 3. Okay. So here we know that it is a red ball and we have to check the possibility that it is from bag 1. There are two different cases. When I have to check the ball is red, when I know it is bag 1 is different to the condition that when I know that the red ball is drawn, now we have to check the possibility of whether it is drawn from bag 1. There are two different cases. Okay, now let us move to this third question. Of the students in a college, it is known that 60% reside in hostel and 40% are day scholars, not residing in the hostel. That means previous year's result report that 30% of the student who reside in hostel attain a A grade and 20% of the day scholar attain A grade in the annual examination. At the end of the year, one student is chosen at random from the college and he has A grade. We know that he got A grade. What is the probability that a student is hostelier? So again, here our sample space is having two partitions. One is a hostelier student and other is a non-hostelier student. So we have two events. So I will say that in solution, I will say that E1 is the event that a student is hostelier. A student is hostelier, and E2, a student is a day boarder. Day scholar or day scholar or day boarder. Okay, here scholar is given, so here we will say that a student is a day scholar. And I will define A as a student get grade A. Gets grade A. Okay, so now possibility of E1 is given. What is given? That the student is a hostelier. Its possibility is 60%. Now 60% means 60 upon 100, that is 0.6, and he is a day scholar. It is 40%. 40% is 40 upon 100, that is 0.4. Okay, and possibility of A by E1 means when we know that the child is a hostelier, what is percentage of getting grade A is 30%. So 30%, that is 0.3, and possibility of getting A grade when it is known that he is a day boarder is 20%, that is 0.2, 20 upon 100. Now we have to find possibility. A student is chosen at random and he got grade A. What is the possibility that he is a hostelier? So we have to find the possibility of E1 when it is known that he got grade A. So now you are means you can solve this problem by yourself, right? So what we do, isn't it the perfect case of Bayes theorem? So by using Bayes theorem, I will say that by using Bayes theorem, we will say that possibility of E1 by A is equals to possibility of E1 into possibility of A by E1 whole divided by possibility of E1 into possibility of A by E1 plus possibility of E2 into possibility of A by E2. This is equals to possibility of E1. Possibility of E1 is 0.6 into possibility of A by E1 is 0.3 divided by, here it is 0.6 into 0.3 plus possibility of E2. Possibility of E2 is 0.4 into 0.2. A by E2 is 0.2. Okay, now we calculate this. 6 3 is 18, 0.18. Whole divided by 6 3 is 18, so 0.18 plus 4 2 is 8, so 0.08. So this is equals to 0.18 divided by 8 plus 8, 16, 2, so 0.26. This will be equals to 18 upon 26 is equals to 9 upon 13. So our possibility that we have grade A and it is a student from hostel is 9 upon 13. So better chances of a hostelier student of getting grade A, 9 upon 13. Okay, one more problem we will see. In answering a question on a multiple choice test, a student either knows the answer or guesses. So again we have a partition of 2, means either a student know the answer, okay, or he guess it. Okay, now let 3 by 4 be the probability that he knows the answer and 1 by 4 is the probability that he guesses. Assuming that a student who guesses at the answer will be correct with probability 1 by 4. Now if he knows the answer, then what is the probability that he is correct? So it is 100%, that is 1. Now what is the probability that the student knows the answer given that he answered it correctly? What is the probability that student knows the answer given that answer it correctly? So student has correctly answered. Now we have to find the possibility that he knows the answer. That means he has not guessed it. Okay, by guessing also we can have correct answer, but we have to find the possibility that he knows the answer when I know that the answer is correct. So here again we have few events. So I will say that E1 is the event that student knows the answer. And E2 is the event that student guess the answer. And A will be the event that student answered correctly. Okay, so we have possibility of E1, that means student knows the answer. What is the possibility? It is 3 by 4. Possibility of E2, that the student guessed the answer, it is 1 by 4. Possibility of answering it correctly when it is known that he knows the answer. So this you should write 1 because 100% possibility. And possibility of A by E2, what is the possibility that he answers correctly when he is guessing? So it is 1 by 4. Okay, let us check. It is 1 by 4. Assuming that a student who guess at the answer will be correct is 1 by 4. So here now we have to find probability, we know that the answer is correct. What is the probability that student knows the answer? So here we have to find possibility of even when I know that answer is correct. This we have to find. Again, by using Bayes' theorem, I will say that by using Bayes' theorem, I will say that possibility of E1 by A is equals to possibility of E1 into possibility of A by E1 whole divided by possibility of E1 into possibility of A by E1 plus possibility of E2 into possibility of A by E2. Now you can see that in all the problems I am trying to use events as E1, E2 and A. Okay. To make the things simple and clear, I am doing this thing. You can assume events like A, B, C, etc. anything. Now here we know probability of E1 as 3 by 4. So let us put the value. It is 3 divided by 4 and this is 1. Okay, because when he is knowing the answer, then possibility of getting correct answer is 1. Divide by, it will be 3 divided by 4 into 1 plus 1 divided by 4 into 1 divided by 4. So this is equal to 3 divided by 4 upon 3 divided by 4 plus 1 divided by 16. So this gives me 3 divided by 4 divided by 3 for the 12 plus 1 13, 13 divided by 16. Okay. So in short, we are doing calculations. 3 by 4 into 16 divided by 13. So 4 1 the 4, 4 4 the 16, 3 4 the 12. So 12 upon 13 will be the correct answer. 12 upon 13. Right? So this is the question. Now I think this much is enough for today's class. Revise these problems again and I will see you in the next lecture with few more problems on the same topic, that is Bayes' theorem. Thank you. Thank you for being with me in this class. Thank you once again.